Probability distribution is a very important concept that is linked with random variable. So let me do a little bit of a review of a random variable. So a random variable is something that it's uncertain. Random variable. So random variable is something that is uncertain and something that we have to understand that it's just a variable. So it's uncertain. Random means uncertain, and variable is something that changes, a value that changes. Value changes. Now that's the concept of a random variable. Now when a random variable is made, we have to find the probability of a random variable, and we make a table out of it, and the table looks like this. So on one hand we have the random variable, and here we have the probability. Now the capital letter is the name of the random variable, and the small letter is the value of that random variable. For example, if the random variable is a number of people who are going to attend a particular ceremony. So now suppose there are 5 people who are supposed to attend the ceremony, and how many people shows up? So x is, suppose, the number of people attending a party. Now altogether, suppose 5 people were invited to the party, and so what are the values? X is this. Now what are the values of the small letter x, meaning the instances of the random variable? So it can be maybe no one would show up, maybe 1 person would show up, maybe 2 person would show up, 3, 4, or maybe everybody would show up. So these are the different instances of the random variable capital letter X. Now every probability written as probability of x equals to 0, probability of x equals to 1, probability of x equals to 2, and so on. Every particular instances of the probability are plotted here. So we have the value. So suppose 0, 1, 2, 3, 4, 5, and every single probability of every value we put it down here, and we can get a probability distribution table. So this is a probability distribution table. Now this is more of a general probability distribution table, and if we have a situation where every single probability is equal, so for example the probability of no one showing up and the probability of 1 person showing up, they are all equal to each other. In that particular situation we call that probability distribution table a uniform discrete distribution. So there are different types of probability distributions. So this one is a general discrete distribution. So we can consider the examples that we're going to do now as general sort of a distribution. So general discrete distribution. So whenever we are talking about probability distribution, there are actually quite a number of different types of distribution. So let me first of all list down the different types of distributions that we have. Now what we have in one instance is, so types of probability distributions. Now the most basic type that we are going to start with is discrete, where the random variable is discrete. So we have one type where we have a general discrete distribution. This is one type of probability distribution table that we have in our syllabus, and we have to do this one. The next type of probability distribution that has a discrete random variable is called uniform discrete distribution. General means it can have any situation. Uniform means specifically where every single probability they are equal to each other. Then we don't have this in S1. With these two are in S1. So this is in the first paper, and in S2 we have binomial discrete distribution, that is in the S2 syllabus, and we have the Poisson or Poisson, the French name, discrete distribution. So these are the four discrete random variable distributions, and this is what we have in S1. This is the most important for S1. Sometimes you can have this question. It's a very simple question, but this is the main question, the general discrete distribution. And if I also mention the different types of continuous distribution, let me write it down here. So for continuous random variables, we have the first type of probability distribution is the general continuous distribution. Then we have the uniform, more or less just like that, the uniform continuous distribution. And we have the normal continuous distribution. We just call it the normal distribution. So only this one is in S1, but these two are in S2. They are not in S1. So the S2 syllabus is these two discrete distributions, binomial distribution and Poisson distribution, and these two continuous distributions, general continuous distribution and uniform continuous distribution. That is more or less the entire syllabus of S2. For S1, we have the general discrete distribution, this type of probability distribution. We have the uniform discrete distribution, which is really so little part of S1 that we can almost ignore it, but this is a major part, normal continuous distribution. The normal continuous distribution is perhaps not only the most important continuous random variable distribution, but it is actually the most important probability distribution, but later on this one. But first, the general discrete distribution. Now, before we get started on an actual sum to see what the sum looks like, it is important to understand that in order to find the probability itself, they usually start off with a formula, with a function with which we can find the probability, and that is called the probability distribution function in case of a discrete random variable, and it is called the probability density function in case of continuous random variable. So the probability is equals to the PDF, which is written as fx. So this is known as the PDF, meaning probability distribution function. So let's take a look at a particular sum. Now they can give fx is given by kx, where the instances of the random variable are 0, 1, 2, 3. So the first question is, form a probability distribution table. So this would be 2 marks. Now, in order to form the probability distribution table, it is important to understand that this probability is equal to the PDF, the probability distribution function. So all you have to do is form a table. So put the random variable capital letter X and the probability capital letter X equals to small letter x. So the values of the random variable are 0, 1, 2 and 3. Okay, now if x equals to 0, fx is k into 0, so this would be 0. If x equals to 1, fx is k into 1, this would be k, this would be 2k and this would be 3k. So this is the table, and you can notice that the table is in terms of k. And the next question would be, and find k. So this is 1 mark and you have to find k. Now in order to find k, you have to remember the rule. The total probability is 100%. 100% means 100%. Cent means 100. Century, 100. So 100 divided by 100 is 1. So we can write 0 plus k plus 2k plus 3k equals to 1. Total probability is 100%. So then if we add it up, 3 plus 2 5, 5 plus 1 6, 6k equals to 1, therefore k equals to 1 by 6. So we found the value of k equals to 1 by 6. That was the question. In question number B, after this question, the next question is usually based on probability. So this would have some parts. So find the probability. Number 1, probability of x is less than 2. Number 2, probability of x is greater than or equals to 1. So let's do this particular sum. So in order to do this one, you have to remember, whenever we are finding the probability is added together. That's called the special rule of probability, addition rule. The addition rule of probability. So whenever you have an OR situation, for example, the probability can be less than 2. Less than 2 can be 1 or 0. Greater than or equals to 1. Greater than or equals to 1 can be 1 or 2 or 3. Remember, this is discrete. They are separate and distinct values. So whenever you have this, you just add it up. You have to add up the probability. So for example, if you have the probability of having R or having B, red or blue, suppose, so it will be the probability of red added with the probability of blue. So for this particular sum, let's do number 1, B1 to be more exact. So probability of x is less than 2 is equals to probability of 0 plus probability of 1. So that's what it means. So we just add up the two. So probability of 0 is 0 plus probability of 1 is k. K means 1 by 6. 1 by 6. So the answer is going to be 1 by 6. Now let's do the next one. I recommend you do one below the other. That is the proper way of doing it. I'm doing it in this way because of space. So the next one is probability of x is greater than or equals to 1. So that means 1 would be included because it is equals to 1, plus it would also be 2, plus it would also be 3. So we just add up the probability. Probability of 1 is 1 by 6, probability of 2 is 2 by 6, and the probability of 3 is 3 by 6. So if you add it up, this would be 100%. Since the probability of 0 is 0, so if you add it up, this is 100% probability. So this is the second question, and the second question deals with how to find the probability. Now the third question is expected value. Find the expected value. Now let me talk a little bit about this one. What is the expected value? When we use the frequency distribution table, we have to find the mean. But in this particular table, where we have the random variable and the probability, we call the mean by a special name. We call it expected value. What is our expectation? Because after all, every random variable has a percentage, and we have a particular expectation for every single value. So that's why we call it the expectation of the expected value. So if you note that the mean mu, population mean mu, is for when we have a frequency distribution table. This is the formula: summation of data into frequency divided by total frequency. So that is the formula. Here we call the mu expected value ex, and it is summation of, instead of this data, it is discrete random variable. It is the random variable, and instead of frequency f we have the probability, and we don't have to write anything divided by, because the total frequency means total probability, and we know total probability is 1. So this is the formula. That's all that we have to do. So the expected value is nothing but the mean, a fancy name for the mean, and we find it the same way that we do before, just instead of data we have the random variable, and instead of the frequency we have the probability. So if we do this sum, so it is going to be, so the answer is going to be, so the expected value is going to be data into, meaning random variable into probability. So random variable is 0, probability is 0, plus random variable is 1, probability is k, that is 1 by 6, plus random variable is 2, probability is 2k, meaning 2 by 6, random variable is 3, probability is 3k, meaning 3 by 6. We can take a look at the table. Yes, so random variable into probability, 1 into k, meaning 1 into 1 by 6, 2 into 2k, meaning 2 into 2 by 6, 3 into 3k, meaning 3 into 3 by 6. So this is how it works. So when we have this, we can actually write, add it up and find the expected value. So let me bring out the calculator. So remember, when we use brackets and addition and subtraction and multiplication, it is really unnecessary because the calculator understands it very well. The only thing the calculator finds it difficult to understand is division. So we can just go ahead and do this. So it will be 1 into 1 by 6 is 1 by 6. It's a good idea not to put everything in the calculator. Do some of the work in your head and do the rest in the calculator. So this is 1 by 6 plus, so 2 divided by 6 is 1 by 3, so 2 by 3. So this is going to be 2 by 3 plus 3 into 3 by 6 is going to be 1 by 2, and this is going to be 3 by 2. 3 by 2. Now you might ask the question, why is the probability 7 by 3, meaning 2.3? How can the probability be more than 1? Because probability is 100%. 2.3 means 230 or something percent. Well, it's very simple, because expected value is not the probability, it is the mean value of the random variable. So remember, there are 3 random variables, so 3 random variables, and you have the mean of that. It is more or less around here. So probability and expected value is not the same thing. Whenever we are talking about the expected value, we are talking about the mean. So remember, this is not the probability, so it can have a value more than 1. That is absolutely fine. The next question that we have to go through, that one is called the variance. Find the variance of x. Now remember, variance is the thing that you have to find before you find the standard deviation. So variance is exactly what we do before. So when we do the frequency distribution table, the formula for the variance, population variance, is sigma squared, is summation of data squared into frequency divided by total frequency minus mean squared. So you can easily figure out what's going to happen here. So sigma squared is written as VAR(x). That's the norm of writing it here. And we can write summation of random variable squared, frequency will be probability, total frequency, meaning total probability is 1, we don't have to write that, minus mu squared. So this is the very simple formula. Now one thing you have to understand, since mu is written as EX, so mu is summation of XP. So summation of x square p is sometimes written as EX squared. It's a fancy way of writing it. You don't have to write it, but it's just a fancy way of writing it. And since mu is EX, so mu squared means EX complete squared. So sometimes variance can be written like this, but if you use this, is absolutely fine, no problem at all. So let's get back to the variance formula. So it is recommended that you calculate this portion like this. So give a huge bracket because it might be long. So random variable is 0, probability is 0, 0 into 0 square, no, Remember, random variable squared into probability. I made a mistake at the beginning. So you see that there can be a mistake here. There is no square on the probability, the square is on the random variable. So 1 square into k is 1 by 6. Then 2 square into 2k is 2 by 6. 3 square into 3k is 3 by 6. So this is this minus mean squared. Mean is 7 by 3. We just calculated whole squared. So let's calculate the variance with the calculator. So 0 square into 0 is 0 plus 1 square into 1 by 6 is 1 by 6 plus 2 square into 2 by 6. 2 by 6 means 1 by 3. So 2 square is 4. 4 into 1 by 3 is 4 by 3 plus then 3 by 6 is 1 by 2. 3 square is 9. So 9 by 2. 9 by 2. So this is going to be 6. Then minus 7 by 3 whole square is 7 square is 49 by 3 square is 9. So this will be 5 by 9. So the variance is going to be 5 by 9. Remember, variance is the calculation that you do before you find the standard deviation, and variance and standard deviation give you a measure of dispersion, meaning the gap between one data from the next data. So we are almost done. The last question that we can expect, it's called coding. Find e 2x plus 3 and variance 2x plus 3. Suppose they have the same coding. Now coding is an easier way of expressing something. If someone tells you the price of something is 30 million, 50 million, 60 million, 70 million, 75 million, 45 million, instead of constantly saying million, you can just, what is the price of this? This is 30. This is 75. This is 45. So you just get rid of the million. So when we say things and try to say it simpler, what is the price of this? Suppose it was 75,000. You can just say this is 75. It took 75. So 1,000 is understood. So this simpler way of saying things, it's called coding. So when we have a coding, expected value of ax plus b, it just means multiply the coefficient of x with the expected value and add the constant with that. That's it. Very simple. So when we do this coding, it is going to be e1. So e2x plus 3 is going to be the coefficient of x multiplied by ex plus the constant 3. So 2 expected value is 7 by 3 plus 3. So this is going to be 7 by 3 into 2 plus 3. So this is going to be 23 by 3. The next one, variance coding, is a bit different. Remember, in variance it's actually sigma squared. So when we do variance coding, we are not actually bothered about the constant. We just take the coefficient of x, square it, coefficient of the random variable, and multiply it with the variance, and the constant that is added, we just ignore it. That's all we do. So here this is going to be coefficient of the random variable is 2, so 2 square into variance of x, and we just ignored the plus 3. This will be 4 into variance is 5 by 9, so this will be 20 by 9. That's it. That's the variance. So this is the question you can expect when you have a question of probability distribution. So let me talk a little bit about what we have talked about. So when we do probability distribution, the first thing that you have to remember that there are different types of probability distribution. So what we do here is a general, discrete probability distribution. So that's what we talk about, and for this type of sum you have to know the concept of what is a random variable. So discrete random variable. So you have to know the concept of probability distribution function, from which we can find the probability and actually form the table. And you have to know the basic concept of probability. That means probability is the mathematics of chance, and when we talk about probability, we are talking about the chance in terms of percentage. What is the chance of this happening? And it is uncertain. You don't know what's going to happen. So probability is the mathematics of uncertainty, and we give a term in terms of percentage. And another concept of probability is probability can be between 0%, where you absolutely don't know what's going to happen, that you're absolutely sure it won't happen, and 100% you're absolutely sure it will happen. And the concept of the addition rule, where if you have something happening or something happening, you just add up the probability. That's the basic concept of probability. Then you have to find the expected value. Expected value is nothing but another fancy name for the mean. You have to find the variance. Variance is what you find before you find the standard deviation, and there is the coding. So that's how it will happen. And when you get a question regarding general discrete probability distribution, the structure will always be like that. They can either start off with a probability distribution function, fx. Remember, fx means the probability is equals to fx, and this is the idea. The next lecture we'll be talking about uniform discrete distribution, where each and every probability are equal.